Okay, guys, in this lesson, we're going to learn how to solve multi-step equations and describe the solution set with some special cases. So remember, solving an equation is simply undoing the operations that are applied to the variable. So for example, in this equation, where we have some unknown value that we're trying to find, so that this left side equals the right side, because that's what an equation is. We have a left side and a right side, and our goal is to find the value that once we plug it in, that this left side will also equal 18. So the operations that's happening to this equation is multiplication. X is being multiplied by 2, and then the other operation is addition. And remember, the order of operations, we would multiply and then add if we knew what x is. So our goal is to isolate the variable so that we can identify what the value is of x. So isolating just means we want to get this x by itself. So we are going to undo multiplication and addition, but we're going to do it in the opposite order of the order of operations. So again, if we knew what x was, we would multiply, then we would add. But to undo this operation of addition and multiplication, we're going to work backward. And we're going to undo the addition by subtraction, and then we're going to undo multiplication by division. So once we get the value of x, this is called the solution. So the way that we got the solution of x equals 6 is we subtracted 6 from both sides, and then we undid multiplication by division, and this is how we got x equals 6. This value of 6 is called the solution. Now, to check our work to see if this value of 6 is the solution, we plug it in for x. So here we have plugged in the value of 6, and now we're going to use the order of operations. We're going to multiply, and then we're going to add 6. So 2 times 6 is 12. 12 plus 6 is 18. And we get a true statement. 18 equals 18. So our solution was correct. So remember, when we are solving equations, whatever we do to the left side, such as subtract 6, we also have to subtract it on the right side to keep it balanced. Then we divided both sides by the coefficient of 2 because we wanted to keep the equation balanced. So again, whatever we do to the left, we have to do to the right. And then one more time, once we got our solution, x equals 6, we plugged it into the equation and we used the order of operations. And we got a true statement where the right side and the left side equal one another. So to undo an equation, we're going to use the inverse operations like we've talked about already. So let's talk about the inverse operations. So we have an operation of addition, and to undo addition, we use subtraction. If we have subtraction and we want to undo subtraction, we're going to use addition. If we have multiplication in our equation and we want to undo multiplication, we are going to use division. If we have division in our equation and we want to undo that operation, we're going to multiply. So these are the inverse operations that we will use. Now let's review the order of operations. If I know what the missing value is of x, our variable, and I plug it into the equation to check our work, the first thing that we would do is parentheses. After parentheses, we would apply exponents if we had exponents in the equation. After exponents, we would either multiply or divide. It depends on which comes first, reading from left to right. And then lastly, we would add or subtract. Again, adding and subtracting are equal in as far as order. It depends which comes first, from left to right in the equation. So here's order of operations. But remember, when we solve an equation, we undo the equation by working backward. So we will add or subtract first, multiply or divide next, and so forth. And the way we will undo these operations is applying the inverse. So everything is in the opposite order in opposite operation when we are solving an equation, which is like putting a puzzle together. So let's illustrate. We have some value of x plus 4 is equal to 12. We're trying to find out what is the value of x. If I add it to 4, I get 12. Well, to undo addition, we are going to subtract, and the value that is missing is 8. 8 plus 4 equals 12. 8 plus 4 is 12, and so I checked my work. So subtraction undoes addition. Here we have some value. We're going to subtract 4 from it to get 12. To solve this, we do the inverse operation of subtraction, and to keep the equation balanced, we add 4 to both sides. We are isolating x, and we get 16. 16 minus 4 equals 12. 16 minus 4 is 12, and we get a true statement. So our solution of x equals 16 is correct. In this equation, the operation is multiplication. 4 times some number equals 12. Well, to undo multiplication, we divide, and we're going to divide both sides by the 4, isolating the x, getting x by itself. And what we do to one side of the equation, we have to do to the other to keep it balanced. So our solution is x equals 3. If I plug this back in, so put our solution of 3 in for x, 4 times 3 is 12, and we have a true statement. In this last example, x is being divided by 4. So we have some value of x, and when we divide it by 4, we get 12. Well, the inverse of division is multiplication. So we're going to multiply by 4 because we are undoing division. And when I multiply the left by 4, we have to multiply the right by 4. These 4's cancel. That's what we wanted. And now we have x is equal to 48. If I plug 48 into the equation for x, so we have 48 divided by 4, that's 12, equals 12. And again, our solution is correct. So the solution is the value that once we plug it back into the equation and apply the order of operations, we should get a true statement. If we didn't get a true statement, our solution was not correct. So in each of these examples, there is one value and only one that once we plug in makes the statement true. Now let's test to see if the given value is the solution. So we're going to plug in the value. So we're not solving these. We're just testing to see if the given value is the solution. So we're going to plug the value that's given in for our variable. Now we're going to do order of operations. We're going to multiply, then add. 12 plus 4 is 16 equals 12. This is not a true statement, therefore x is not the solution. Okay, our next example, we have x being divided by 3 minus 8 equals 3. We're going to check to see if 12 is the solution, so we plug it in for the value of x. We're going to Apply order of operations. We're going to divide and then subtract. 12 divided by 3 is 4. 4 minus 8 is -4. And -4 does not equal 3. So this is not the solution. Okay, now let's see if this solution is 4. We're going to do parentheses first. 4 plus 2 is 6. And then we're going to multiply. 3 times 6 is 18. And we get a true statement. So x equals 4 is the solution. Okay, now let's see if in this equation, if our solution is 10. So we're just first going to substitute it in. We're going to do parentheses before we multiply. 10 plus 4 is 14. When I multiply by 1/2, that's the same as dividing by 2. So we get 7 equals 8. So 10 is not the solution. So this is how you check your work, guys. So if we were to solve this, and let's say we got x equals 6, and we plugged it back in, we would see our answer was not correct. So we would redo this. So this is always a great tool, a strategy to check your work. Just plug it back into the original equation, apply order of operations.